So first entry on the list of the finalists comes from the AIT. You all know them, but perhaps you don't know yet the fast inline 3D surface scanner, exposure, photometry that combines the advantages of 2D and 3D technologies within its special applications, and it promises higher throughput, reduced cycle times, and even higher quality requirements can be surveyed during this approach. So let's not lose any more time. Get him on stage. Please welcome Austrian Institute of Technology, Markus. It's your stage now.
Thank you very much. Thank you very much, Christian. Thanks to the jury that selected us to the shortlist here. And it's a pleasure and honor for me to present now the first innovation. Let me first introduce myself. My name is Markus Clabian. I'm the head of the group of high-performance vision systems at the Center for Vision Automation and Control at the AIT, Austrian Research Institute of Technology. I today want to show you why 3D is important and why fast 3D is important. During the Corona crisis, we are used to 2D flat screens. And here at the trade show, we see that 3D is more than that. But the fast inline surface scanner that we provide here is a technology that enables you to get 2D and 3D information very fast and synchronous. But let me first introduce the AIT. AIT is the largest applied research institute in Austria with 7 centers of competence covering important topics relevant to the prosperity and security of a country. Our group is part of the Center for Vision Automation and Control, and we are driven by the demands and the needs of the industry, and we would like to automate more and more complex processes. The center consists of 3 groups. One is the high-performance vision systems group, dealing with inspection systems. The second one is the group of assistive and autonomous system, where particular autonomous machines and autonomous driving is one of the key interests. And third, the complex dynamical systems group, with which the aim to close the loop between sensors and actors, between inspection and optimization of quality. With this mission, AIT is and has been in the last years an innovation hub, and we contributed to many of these award sessions, and it's not the first time we are nominated, and also not, we also won sometime this award. So we are happy that AIT is one of the innovation contributor also to this trade show. Our mission always is to bring the innovation from the universities to the industry, but also back to get the needs back from the industry to bring it to the science community to solve novel issues. And what are the needs actually? Imagine you are responsible for a manufacturing or production process. This involves usually strong material flow, be it in a roll-to-roll process, being in the printing process, or be it foils, metallic surfaces. There are objects moving very fast, so you need speed, and this is going to be more and more that you need fast processes. If you have to acquire the quality of your product, you can currently choose from following options. Either you do a 2D imaging of your product. Well, 2D can really well give results quite fast and deliver good results. But unfortunately, there are often pseudo effects that you cannot spot because they are in 3D. They have some 3D structure that you don't see in the 2D image. There are a lot of 3D imaging systems, of course, but usually they are quite slow. They are computational very intensive and also sometimes quite expensive to be used, and usually not suited to a real inline process. Let's speak about several meters per second, then this is usually not applicable. Of course, there are the 3D profiling systems which can do quite fast things, but also the speed, the line rate is medium, and you need additional laser illumination, and you usually don't get really an image. So there is the need to have 2D and 3D imaging fast combined to really realize high-speed production processes. The innovation that we show here is now that we bring together two things. On the one hand side, we have the fastest line scan camera in the world with 600 kilohertz line rate. And on the other side, we have high-speed algorithms that can detect the surface normals and the surface structure. This is a principle that is not novel. It's the surface structure from shading process where you can detect the albedo and the surface normals from one image from multiple imaging by multiplexing the light sources. So you illuminate the scene from different directions with different light sources, and then you can detect as well the albedo as well as this 3D information. And we have now, for the first time, combined this. The fastest camera combined with high-speed algorithms, and this gives you exposure photometry. Exposure photometry is the solution to all the ultra-fast inline 3D surface problem. You see here a schematic drawing and also the setup, how you can see it afterwards also at our booth. This scene is illuminated by 4 LEDs, line lights, and in time multiplexed mode illuminates the scene. Left hand, you see this setup that can be seen then also at our booth. And beneath the camera, there's a rotating roll or the material flow that has the object beyond. You see it here also in another schematic drawing where the material transport is seen here and also the lights illuminating. And the material transport is then encoded optically, which gives the trigger signal for the camera and the LED lights. And from the camera directly, you get the images. Images that show as well the 2D and the 3D structure. Here, a short video demonstrating this. You see the object moving under the camera, the 4 lights, and the camera itself. And this is the result that can be shown. A very detailed, crystal clear image of the object on the left-hand side. And on the right-hand side, you see only what is left if you remove the pure color information, namely the 3D information, the image gradient. You can clearly see on the right-hand side that the wrinkles of the paper are visible, that the bends are visible. And in addition, you see also that such a banknote is printed in 2 printing processes. One is an offset print, and the second is an intaglio print, which means that the paper is really deformed by the colors pressed into the paper. And this can be clearly seen in that image. But notice that this is done at a very high speed, 10 meters per second in a resolution of 50 microns. And both images are delivered by the camera directly. So all the calculations are done within the camera. You can see it here, some other examples, a wallpaper, a leather, and also a battery electrode in which the 2D and the 3D structure are clearly visible. And what can this really help? Well, it can really help to distinguish between the simple albedo image and the gradient as well and the depth information. So you see here an example where on these battery electrodes you see a lot of defects. But the question is, which of these defects are real ones? And this can be decided by the gradient and the depth image, because they clearly show where the dust is, where the marks are, and where the real holes are. So to summarize, okay, this has been somehow misaligned. To summarize, we have an extremely high-speed surface information that we get from this innovation, exposure photometry. It delivers high speed. It delivers up to 600 million points in albedo in the normals, and a line rate of up to 300 kilohertz, meaning for a speed of 30 meters per second, you get still a resolution of 100 microns. It is robust because it helps you to really detect and to distinguish between small scratches and defects, even in uniform surfaces. And it highlights the local deviations in the 3D structure from ideal surfaces by the shading effect. And the solution is compact because it processes all the information directly on the camera and delivers the images over its 10 GigaVision interface to the network, to the PC, to whatever you need the result. So we can summarize. This solution is ideal for high-speed defect detection or process control where 2D and 3D is needed in a very fast manner. Thank you very much. I would like to thank also the contributors within our group, which have done a great job to do this innovation. Thank you very much. And back to Warren, I think.
Yes, back to Warren. You are fully right, back to Warren.